underscore table?
What?
Yeah. You can edit it and stuff? Mine's stuck. I tried to download it.
Oh, so this happened in, I'm sorry, I read it, guys, had to completely shut the laptop and restart everything.
Like sign out?
Yeah, sign out, no sign out.
Z. Z.
Yes.
Another
We're having a
day.
lot of technology problems.
No, I didn't say it, date
And the date of the dollar.
Another day, another victory for the OGs. Taking on.
Okay. So, what we're going to do is we are going to kind of break it down lesson by lesson.
No, my.
What number do you?
What that sound?
So why don't you use one for now?
I don't know what that was, guys.
So let's talk about 1-1. 1-1 is to determine whether something is a function, plugging into functions. Let's look at the example that you see here. Okay, it says determine whether y squared minus 8 equals x is a function of x. And if you look, anytime you have a square, an even power on a y, it makes the thing lay on its side. And if we looked at the graph, that's why that one is not a function. You can also tell, because it gets that plus or minus. So every x that we plug in, we get a positive version and we get a negative version. So that's a no, okay? So let's go over and do these ones right here. That's related to that. Okay, so 11 says, is this a function of x? If you can solve it for y, and if your y is very simple, that's one way to kind of determine it's a yes or no. Think about what this is. Both the x and y are separated. It's a linear equation. If we were to graph it, it's a line. So that's also a yes. Now, from a table like 13, a table, you just have to look at the x's only as long as the x's are all different, and that's also a yes. Okay. 14's an easy one to determine it's a no.
About 12.
I'm getting there. 14's easy to tell it's a no because of the fact that that vertical line test. Okay. The weirdest one to me is 12. Now, if it's a cube root, a cube on the y, when you go to solve for y, if you take the x over to the other side and add it, and then you cubed root it, unlike a square root, square roots get the plus or minus, fourth roots get the plus or minus, sixth roots get the plus or minus. If this is an odd power and you were to graph it, it actually passes the vertical line test. So it's not just that y has a power on it. If the power is even, it won't be a function. If the power is odd, it will be. And so this one is also a yes. So if that's a y to the fourth, no. Y to the second, no. Y to the eighth, no. But a y to the first or y cubed, it will be. As long as the x's and y's aren't touching, there you go. Okay. Now, the next thing that we did in section 1.1, we did plugging into functions. So if you notice, we have this g of x function over here. To find g of 2, you see how they've replaced the x's with 2's. Once you do that, you do have to follow order of operations. So be mindful of that, okay? So let's do some of these ones right here. Okay. So f of 5, I don't think it's a bad idea to write it directly under the actual function. So every place we see an x, we're going to replace it with a 5. That's as easy as it is. You don't have to do anything more than that. But you do have to be mindful of how order of operations work. Please excuse my dear Aunt Sally. So we would do the 5 squared. Then we would do 3 times 5. And here's another mistake some kids make often, is they want to do addition before subtraction. And it doesn't work like that. Addition and subtraction happen as we occur to those things from left to right. So you have to do 25 minus 15. You have to get 10, and then you have to add 4 for a total then of 14. Okay, so just be careful of that. You also should know how to plug in things like what we see in 16. I'm going to write the original here above, so that right below it I can plug that in. So I think it's sometimes a really nice idea to have the original written and then have immediately underneath it what you're plugging in. So we're replacing all of our x's with negative 3x. That's our new input. We're going to input it and then see what happens. Okay. When we input it, we get negative 3x squared minus 3 times negative 3x plus 4. Now, there's not a ton you can do to this, but I want you to always get in the habit of simplifying as far as you can go for this next step. Now, we have a negative 3x squared, which means negative 3x times negative 3x, okay? So the negative times the negative will make a positive, 3 times 3 will make a 9, x times x will make an x squared. This next piece, we have a negative 3 times a negative 3. It becomes a positive 9, and the x has nothing that's going to change it, so it just gets attached to it, and then we have a plus 4. Don't try to go further. There's nothing else that's asked of you. When you input into a function, you input, simplify, stop. So we inputted, we simplified, we stopped. There you go. That's as far as you go. Okay. Are you guys good with 15 and 16? Does that make sense how those worked? Input, simplify, stop. Okay. Now, one of the hardest things in section 1.1 was about domain. Okay. There are 3 facts that you want to know about domain. Okay. The first one is that the domain of polynomials is all real numbers, negative infinity to positive infinity. So 17 is a domain of all real numbers. Here's why. The domain are the x's you are allowed to plug into the function. I can plug in whatever the heck I want into that. There's no restrictions. Think about if you go to plug it in. You can plug in positives, you can plug in negatives, you can plug in fractions, you can plug in anything you want into this. If you were to look, it is a parabola that eventually stretches out to the left as far as you want, stretches out to the right as far as we want. There is no restriction. So if this is a polynomial, so polynomials are like 5x squared plus 7, or minus 17x plus 1, x plus 2, 4x squared plus 3x minus 6, 5x to the 4th plus 3x minus 8. Those are very simple kinds of things like that are polynomials. They always have no restrictions. You can plug in whatever the heck you want. Okay. Now, the second one you have to know are fractions. For fractions, the domain, the bottom cannot equal 0. But everything else works. So I'm talking about 19 and 20 now. 19 and 20 are fractions. So the only value I cannot use are where the bottom equals 0. So first just take 19, set the bottom equal to 0. 20, set the bottom equal to 0. We need to find those values that mess up that fraction. Well, a plus 5 equals 0. If we subtract 5, that's at negative 5. So that's the only value we have to skip. For 20, that factors to be x plus 2 and x minus 2. So we cannot be negative 2. We cannot be positive 2. Okay? Now, how do you write that in a correct sort of pre-calc algebra 3 sort of way? To skip negative 5, I can go everything up to negative 5, and I only skip, you only see that skip right there. So that the parentheses are saying, hey, I'm getting super close to -5, but I'm going to jump across it. There's something there. There's a problem. Okay. 20, we have two values to skip, -2 and +2. Just kind of follow the number line. I'm going to go from -infinity up to -2, skip it, up to +2, skip it, and then I can keep going. As you'll notice, there is a skip here and a skip here. I've skipped -2. I've skipped +2. In order, from left to right, that interval notation just follows the number line. I'm good, I'm good, I'm good. Oh, got to skip -2. I'm good until I get +2. Got to skip it. And then once I hit +2 and go on, I can keep going forever and ever and ever. So that's what that notation means. The last type of domain that you have to worry about is square roots. Now this is only concern for even index roots, square roots, fourth roots, sixth roots, eighth roots. In a square root, the domain will be where the inside is greater than or equal to 0. Okay. The square root's domain is where the inside is greater than or equal to 0. So that's all you do mathematically. Take the inside, 6x minus 3, set it greater than or equal to 0, see what the heck you get. Now you're just doing inequalities there. Inequalities, here's the rule. Here's the main rule for inequalities. For inequalities, if you multiply or divide by negative, flip the sign. Otherwise, there's really no other rule to worry about. So this would be 6x is greater than or equal to 3. So x is greater than or equal to 3/6 or 1/2. So think on the number line. If I say, oh, you are greater than or equal to 1/2, it would be this shaded to the right. So your answer follows that number line. It's the exact same thing. So our answer for 18, our domain would be from 1/2 to infinity. If you were to pull these up into Desmos, 18 would have a graph that starts at 1/2 and an x value of 1/2 and goes to infinity. There's no graph on the other side. For 19, the only separation in the graph is at -5. 20, there should be a separation in the graph at -2 and +2. 17, the graph has no jumps, holes, gaps. It's a perfect, wonderful domain from -infinity to +infinity. So the graphs will also check your work. So if you were unsure if you did your algebra right, throw any of these into Desmos and the graph's domain should line up with the graph that you see. Okay. Any questions about how we find domain? Okay, there's just 3 rules you have to remember. If it's a polynomial, it's all real numbers. If it is a fraction, set the bottom equal to 0 and throw that value out. If it's a square root, set the inside greater than or equal to 0. Do the math, you'll find the domain. Okay, we good? Does that make sense how that worked? Good? Okay. Now, obviously, our chapter test is going to be when we get back after Christmas break. So it'll be that week of December 1st. That week, when we get...
Christmas break.
Oh, not Christmas break. Thanksgiving break. You see how much I want Christmas break to be here. Anyway, after Thanksgiving break, so December, somewhere in the week of December 1st, probably either that Tuesday or Wednesday, we will have a test over this stuff. Study over break, pull open math one time, and either watch these videos again or pull up this document. How did I get those things, okay? You can pull up your old notes over 1-1. So if this is 1-1, that is everything you need to know for 1-1. And now let's move on to 1-2. Okay. So 1-2, it says to use a graph to find the domain and range. So let's take a look at 21 and 22. Let's practice finding the domain from the graph. The domain starts at the left side of the graph goes to the right side of the graph and asks what x values have I ran into. So let's do a domain for each of them first. The domain for this one, I started at -8. The x values that I use happen until +8. My domain includes -8, goes to +8, and has everything in between. There were no holes or jumps or problems in the graph from -8 to +8 are the x's that I used. You can almost think of it as if this put a little shadow, if this was the ground, if this put a little shadow on it, the shadow would cover -8 to +8 with it, no problems. That one good for the domain. Okay, now let's look at 22's domain. If this had a light shining up on it, okay, think about if it put a shadow on the x-axis. That's a really good way to kind of think about it. We're looking at what x's we went to. We could go to the left as far as we want. Infinities, remember, always get a parenthesis. If we walked across it from left to right, I am using all of these x's until I get to here. And then you always ask yourself, can I stand at an x value of 2 as long as there's one of those locations that have a closed-in dot? Yes. So I don't have to worry about breaking it at 2. I have a spot to land at 2. And then I can jump to 2.1 and 2.5 and 2.7 and 3 and 3.1, 3. And I can go forever to infinity. So even though this is in 2 pieces, all x values are accounted for, so your domain goes from negative infinity to positive infinity. If you went negative infinity up to 2 and included it, and then went from 2 to infinity, I would accept that. You're showing the domain for each piece. But technically, the 2 is included, so why waste your time writing all that out, okay? Okay. Now let's do range. Range is from bottom of the graph to top of the graph. So remember, range are your y's that you used from the bottom of the graph to the top of the graph. Domain are the x's that you used from left to right. Okay, so let's go from the bottom of our graph to the top of our graph. What heights do we hit? The bottom height, the lowest this graph gets is 0, right? The highest this graph gets is 8. The range for this graph is from 0 to 8. I can stand at 0. Now I'm over here when I'm at a height of 0. I can stand at 8 and everything in between. I can find somewhere to stand for any of the decimals between 0 and 8. Let's look at 22. The lowest this graph can go is negative infinity. The highest this graph can go is negative 3. I can stand there only because that one dot is colored in. That's the highest I can go. There's no other heights higher than negative 3. And so our range goes from our bottom of our graph, negative infinity, to the top of our graph, negative 3. Include it because that negative 3 was colored in. This piece just repeats these y values, so you don't really need to do anything about it. But you could, if you wrote the 2 pieces together, it's just redundant, so you don't really have to. Okay, everybody good with 21 and 22? How to find it from the graph. Domain are the x's, go from left to right. What x's do I come across? The range are the y's, go from the bottom of the graph to the top of the graph. And then that's what you look for every time, okay? Last thing from 1-2 that you need to know are intercepts and zeros. Y-intercepts, you're going to let x equal 0. Zeros are also called x-intercepts. We're going to let y equal 0. So you let the opposite variable equal 0. So let's do each. Let's do the y-intercepts first, and then we'll shift and do the x-intercepts. The y-intercepts are easier. We're just letting x equals 0. Okay, so the first one, you just got to plug in 0. You get 4 times 0, which is 0 minus 9. So we get -9. That's the nicest. Y-intercepts are easier mathematically to do than x-intercepts. They just are. Okay. So that's 23. Let's do 24. If we plug in 0, we get 0 minus 27, or -27. For 25, just plugging in 0. Y-intercepts are so great, we just get to plug in 0. And then we get 0 minus 0, or 0. That's good. And then same thing, 26 is great. If we plug in 0, we get the square root of 2 minus 1. Now, I don't know what the square root of 2 is mathematically. I mean, it's like 1.4 or something. But who cares? Just leave it like that. That's the exact answer. Don't worry about simplifying or anything. It is what it is, okay? So y-intercepts are wonderful. You just plug in 0, you do the math, you stop. It's an input. Yeah, you don't have to do anything else. X-intercepts are harder. Those are zeros. And that, we're going to let y equals 0. Okay, so if it says zeros or x-intercepts, they mean the same thing. We let y equal 0. That's also f of x equals 0. Okay. So where the f of x is sitting right there, we got to make it 0 and we got to solve it. So 23 is really where 4x minus 9 equals 0. See how there's a lot more math to do. And there usually is 4 zeros compared to y-intercepts. Because these are functions, you'll only ever have one y-intercept, but you could have multiple x-intercepts depending. This one only has one because if you add 9 to the other side, you get 9, divide by 4. Just leave it 9 over 4. I'm okay with that being your answer. You can't do anything more with it. Your y-intercept is 9/4. Now, how could you check your work on these? Well, Desmos can check all of our works. If you plug the function in, if you type it on a line, it should hit the y-axis at -9, the x-axis at 2.25 or 9/4. Okay? Let's do the next one, 24. We're going to set x squared minus 6x minus 27 equal to 0. Now, we haven't practiced factoring a lot, but you should remember, hopefully, how to factor that type. We need the factors of 27 that have a difference of 6. 27 is 9 times 3. 9 and 3 subtract and get you 6. So those are the numbers we're looking for. Let me go over the rules a little bit. Sorry, I was thinking the word number 6. Okay, so 9 times 3 has to equal 27. If the back is negative, one's negative, one's positive. Just look to the middle. That should match the bigger number. So it's -9. So when you take -9 and +3 and add them together, you get -6. Once you've done that, to solve it, we separate it. X minus 9 equals 0, and x plus 3 equals 0. Think how much more work 24's x-intercept was compared to 24's y-intercept. They're just mathematically very different. So we get x-intercepts or zeros at +9 and at -3. So if you were to go into Desmos and type 24's f of x equals x squared minus 6x minus 27, you should hit the y-axis at -27. You should hit the x-axis in two places, +9 and -3. And the reason that is because it is a parabola that looks something like that. And so you hit the x-axis in two places and the y-axis down there at the bottom, way low, okay? Everybody good with 24's x-intercepts? Okay, let's do 25. let's just save space. F of x is 0. So that is where the function equals 0. That's why they call it the zeros of the function. Where is the function equal to 0? They both contain what variable in 25? X. So that means we can remove an x from both pieces. Now that means the x's that were there, the powers go down. On that back piece, that 16 only had an x, so when we take it out, it just stays an x. This factors one more time. X plus 4, x minus 4. So this particular graph has 3 places that it hits the x-axis. It has 3 zeros, and many times, if the power is a cube, it'll have 3 zeros. If the power is a 4, it'll have 4 zeros. Not always, but there is some relationship there. We get zeros or x-intercepts at 0. Don't forget that front one. -4 and +4. So if we were to pull open Desmos, it hits the y-axis at 0. It hits the x-axis at 0, +4, and -4. Okay, so that is 25. We got one more of these ones. Let's do 26. We're going to write down the function and set it equal to 0. Now here's square root equations. Let me remind you how to solve it. You probably did these in Algebra 1. You get the square root by itself by adding 1 to the other side. So that -1 on the left becomes a +1 on the right. And then the way that you get rid of that square root is by squaring both sides. When we do that, the square root drops away, and then it becomes something very simple. And then you subtract 2 from both sides. You get x equals -1. So that one only has 1 y or x-intercept. Take a look for a minute. We know what that looks like. Okay, I'm going to draw it for you, kind of. It looks like a square root like that. So it makes sense that it hits the x-axis at -1, hits the y-axis at square root of 2 minus 1, which is like 0.4. So yeah. So the graph will check your algebra for you. So use Desmos, check your algebra. Okay? Okay. So that is what's in section 1.2. Any questions there? Okay. Let's talk about 1.3. Let's do 32 and 33. We're not going to do that for the now. Maybe we'll do it another time. But I'm only, from 1.3, I'm only concerned about finding the end behavior from a picture. Finding the end behavior from a picture. For an end behavior from a picture, we are talking about for this one, this end and this end. We don't really care what's happening in the middle. Here we're talking about this end and this end. So we're thinking about as we go to the left, as we go to the right. Okay? Okay. So as we go to the left here, we're going up to positive infinity and down to negative infinity. As we go to the left here, we are heading to a height of 0 to a height of 0. Now let me just remind you how to write it more formally. So as x goes to the left, our y is going up. As x goes to the right, our y is going down. So that's I think the way we can continue to write it. If you know that limit stuff we had done, feel free to write it like that. But that's all I need. This goes to the left, the y is going up. This goes to the right, the y is going down. So this really means up, and this means down. Okay. Now 33 is just different because we're heading to not up or down, but heading to 0. So the left, the y is going to a height of 0. The right, the y is heading to a height of 0. So sometimes your ends are heading to a height, and if they are, they'll look like this. And sometimes they're heading to infinity, if so, they'll look like that. That's the only thing you need to know about end behavior for the test. Okay, so that is 1.3. So does that make sense for that? Okay. Average rate of change. The only ones I want to do from this section are 36 and 37. Okay, so that's the only thing that we need to worry about for end behavior. Okay, let me write down the average rate of change formula. The average rate of change is really just the slope. So it is f of x2 minus f of x1 over x2 minus x1. Now, if you want to write y2 minus y1 over x2 minus x1, that's the same formula. But since we're having it in function notation, it's a good idea to practice it in function notation. If we start out with 36, this is x1, y1. Okay, so let me remind you how to do these. The first thing you always do is plug in your, these are both x's, I'm so sorry. That's x1, this is x2. Okay, so the first thing we do is we plug in both x's. So we have to, in this case, plug in 0 and plug in 2. So that we know what y values go with it. So we're really looking for the point that 0 makes and the point that 2 makes. So that means that I'm starting at an x value of 0 and I'm stopping at an x value of 2. If I plug in 0, I get 0 plus 0 plus 1, or 1. If I plug in 2, I get negative 8 plus 6 plus 1, or I also get 1. No, I don't. I get negative 1. Okay. And then once we do that, let's see here. So it's just the slope. So we're going to do f of 2 minus f of 0 over 2 minus 0. Now the reason that this is nice to write, because look, you have it kind of the order nicely written. So this becomes 1 minus, negative 1 minus 1 over 2 minus 0. So that's negative 2 over 2, or negative 1. And I don't think we have to do 37. It's the same idea. So you plug in both x's, you find the y's, and then you plug them into the formula. So that is a formula you definitely want to have memorized by the test. I'll give you a function, I'll give you an interval, I'll say what is the average rate of change along that interval. So it's really, and you could even write y2 minus y1 over x2 minus x1. Same thing, okay? The points were 0, I got it plugged in 0, I got 1. I plugged in 2, I got negative 1. So if you use the traditional slope formula, it will work as well. It's the same thing. Okay. So that's all you need to know from 1.4. Let me pull out a little bit from 1.5, a little bit from 1.6. We'll probably be working most until the bell, because tomorrow we're going to do the practice test. So that's not till tomorrow. Okay. So let's look at these ones. They are asking you to describe the transformation and to graph it. Okay. So I only want to do from 1.5 very quickly. 38, 39, and 40, okay? So 38, the parent function is our square root, okay? The x minus 3 on the inside, just set it equal to 0 to see where the center has moved. So that means we've gone 3 to the right, and outside we don't have to really do anything. If it's positive, it goes up. If it's negative, it goes down. Okay. So all that you want to do for 38 is take your original square root function, jump 3 to the right and up 2. And then do your swoop to the right. Okay. So that's 38. Let's do 39. If you set the inside equal to 0, you see that it is moved 6 to the right. Remember subtraction, like this one would move 7 to the left. It always does the opposite on the inside. Okay, so we're going to take the square. So remember the parent looks like this. And we're going to flip it. We're going to move it 6 to the right. We're going to flip it, and we're going to move it down 5. Okay. So if we move it 6 to the right and flip it upside down, its vertex is there, 6 to the right, 5 down, and it's going to be flipped upside down. That's what I would need as far as the graph goes. Let's not worry about 40 right now. Let's just do 42, and then we'll be done with this section. This is the square root function, and if we want to move it 2 to the left, then our new equation has to be the square root of x plus 2. Because remember, it does the opposite on the inside. If you add 2, it'll move it to the left. If you subtract 2, it would move it to the right. So don't worry about any more from 1-5. We'll practice more of it tomorrow. We'll practice more of it when we get back. Okay. Function operations. Let's talk about 1-6. Now, I'm only going to do time-wise. Let's just do 44 and 48. I don't even know if I'll do all of it, but okay. I might just set it up for you. Okay. For 44, they want you to add, subtract, multiply, and divide the functions. Okay. To add the functions, you just list them with a plus between them. Combine like terms. That's it. You do nothing else. I'm not even going to worry about actually doing that. Okay? Subtraction is the one where you have to put our second function in parentheses, and then you would have to distribute. I'm not going to waste time doing that. I think once I show you that, I think you'll remember how that goes. To multiply these functions, you got to put them in parentheses, and then you've got to distribute. Distribute, 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 distribute. You know, you'd have 6 distributions. To divide them is probably one of the easiest ones because you can't do much of anything. You just write the f function on the top. You write the g function in the bottom and then be done with it. Just stop, okay? So for adding, subtracting, multiplying, and dividing, the weirdest ones to me, subtraction, make sure you put the second function in parentheses. Multiplication, make sure that you distribute, okay? At this time, please, I know I want to still keep talking a little bit, but could you please hit, if you're doing this on your thing, please save it. Hit save as, just so we know what you've written so far is saved. Please hit save as, okay? We're going to keep talking a little bit of 48. And then we'll stop here. Tomorrow we will talk about 1-7 and then the practice test. Now, 48 says to find f of g of x, g of f of x, and f of g of 2. Now, I don't think I'll have time to do many, but f of g of x. We're going to take the f function and plug in g of x. Many of you wrote this notation on the test correctly, but then you just, that last execution you didn't do right. Rewrite it with the g sitting there. So g is 2x squared minus 8, sit it there. And then plug it into f. So that's 4 times that input minus 11. And then you would simplify. Okay, we'll stop there. Save it again. Turn it into where it says chapter review part 1 maybe. Tomorrow we're gonna do one more review so that next week we're gonna be helping with turkeys on Monday.